All right, welcome everyone. We'll wait a few minutes for everyone to funnel in.
Funnel in like a funnel cake?
Or like a mole tunneling through.
Oh, tunnel in.
Tunnel in. If I click on stuff, do you guys see weird gray squares over the screen?
Mm-mm.
Not right now.
Oh, thank God. All right, cool.
All right, so welcome to number 5. So I feel like we've been at this for a while now. Tonight you'll have a treat, EradiMCATe the moles. So I think we're doing some Gen Chems.
Is that how you say that word?
I don't know. Feel free to correct me. Like
I've been wondering
practicing,
this whole time.
practicing all day.
One thing while you're filtering in, if you change in Zoom, if you go to the chat area and change where it says to, change that from hosts and panelists to everyone. Otherwise, only we will see your brilliance, and we want everyone to experience it.
But yeah, feel free to chat where you're coming from. Pretty much all over. So wow, Canada, Jersey, East Coast, East Coast.
Whoa!
Oh, it's a strong Canadian showing tonight.
What is that?
Yeah, and congrats everyone for finishing a semester, getting ready for the summer. So thank you for showing up on a Thursday night when you're ready to be free. Ooh, Hawaii.
Wow.
Sounds nice.
Is it like 2 o'clock in Hawaii right now?
It's like I'll be ready for bed and getting their day started.
It's 1. Okay. Oh, that's nice.
We were just talking with one of our content developers earlier who's in Hawaii. And then we were looking at property in Hawaii.
They're on a new home.
I feel guilty because I was meeting with him and I realized that it was like 3 in the morning and I'm like, wait a minute. What are you doing up so early?
Oh my God. Just a classic 9 a.m. meeting for you, I guess.
Right, exactly. All right,
During
I guess
pandemic teaching, I had a lot of students who were just all over the globe, like coming into Zoom classes at like 4 a.m. for them. I thought, oh, this is terrible. I'm so sorry.
and we'd also love to hear from you. So who's new to Sketchy? Just kind of throw a 1 in the chat if this is your first time with us. And then you can throw a 2 if you've been here forever.
Been here 2 or more times. Yes, Kendra, don't worry. No one can see you or hear you for that matter.
Sweet. So a good mix of returnees and new folks. All right, I think we should get started.
Shall we get this
I'm
shot?
wondering why we all are moles, or in Ben's case, guacamole. Yeah, so welcome everyone. I'm Jess. I'm the Director of Undergrad Education, which includes our MCAT program. I have a PhD in neuroscience and My favorite carnival food, which will make sense once we get started, it's actually lemon shake-ups. So I'm boring. I don't like all the fried food
What
and the
is
sweet
a
food.
lemon shake-up?
What
Just
is it?
squeeze lemons. It's like basically lemonade, a fancy version because you have to shake it,
Oh,
get
interesting.
that air in there.
A little frothy.
Yeah,
Nice.
add a little salt, maybe something. I don't know.
Hey everyone, I'm Ben. I'm the creative director here at Sketchy. I used to be a urologist, and then I realized that my true destiny was in making cartoons for you all. I once had this piece of bacon at a carnival that wasn't like, don't think of a strip of bacon like you get at Denny's or whatever. It was like a chunk of bacon, and it was somehow braised, but also crispy on the. It was amazing. It's like I've been chasing that dream ever since. I've never found anything like it again. So.
Hi, everybody. I'm Jen Vioria. I'm a chemistry professor, and I teach organic and general and also inorganic. My PhD is in chemistry. And when I was a kid, we had these things, they were called elephant ears, but I just Googled elephant ears and that could mean something else. They were huge, and I guess they're funnel cakes, and they're so good. That's my favorite, one of my top 10 favorite foods.
Hi, everyone. I'm Rachel. I'm a creative story developer with Sketchy. My proudest credential isn't any letters after my name, but my shelf full of whack-a-mole prizes I've won on the boardwalk over the years. And in terms of carnival food, I love fried Oreos. I would eat them all day. But don't give me an unfried Oreo because I think those are disgusting. So overrated until you batter it and deep fry it.
I find this so fascinating.
All right, so what are we up to today? So we'll keep our intro brief, and then we're going to walk you through this awesome Gen Chem lesson. We'll definitely have time for Q&A, but at any point, feel free to throw questions in the chat and also use the Q&A function in Zoom. And then at the very end, we will actually give you a small survey just because we love to hear from you, get your feedback. And then we'll give away a 6-month subscription to Sketchy. So stay tuned for that.
It's nice to see a lot of new folks here. And if you're wondering what Sketchy is, it's a visual learning platform. Hopefully all the cool pictures and art have made that clear. And certainly when you go through the lesson with you, you'll really understand what that means. Sketchy has been used by more than 400,000 students at this point. And I was one of them once upon a time when I was in med school, where it's really a key resource because it makes the material fun, it makes it really stick, and because of the reason that we sort of all really care about, it improves your scores. If you're wondering if Sketchy would work for you, if your cells make ATP, then Sketchy is for you. But if you want to remember stuff really fast, if you want to remember it forever, it really sticks in there. And if you want to genuinely, I swear to you, actually have fun while you're studying, then Sketchy is for you. I know I sound super biased, and I am, but remember, I did actually use this as a med student, so all these things are true, independent of me, for you. I promise.
And then, yeah, if you're curious about the Sketchy MCAT program, our content actually spans 8 different courses, and each one has a unique theme. And currently we have around 270 lessons covering high yield content. And I think Ben can speak a little bit about kind of the creative side of this universe, of this unit for Gen Chem.
Yeah, so one thing that's super cool that we've done in the MCAT program at Sketchy is each course, so Gen Chem and Orgo and Physics and Cell Bio and so on, has a different theme so that it's really easy to jump back there in your mind. And so the theme of Gen Chem is a kind of extended family vacation with the Dalton family that goes awry in any number of different ways. Shark attacks, skiing accidents, as you can maybe sort of see from that thermochemistry one, sometimes occasionally bad drug trips, sort of the usual family vacation stuff. But so today we'll join the Dalton family at the carnival.
Neat.
Cool. So yeah, this is our setting here. Our whole electrochemistry and solutions unit takes place at the beach because the ocean is the biggest solution you can find. And so the Dalton family is here at the beach for this sketch. And then you go forward. This fellow we've added up front in the very trendy polo shirt is our first symbol. And he is just serving, he's concentrating hard on that packet of powder and his water because he is our reminder about concentration. And Jen, if you want to give us a little reminder about what?
Oh yeah, concentration. So in addition to being that face, concentration is the amount of solute you have dissolved in a solvent or in a solution, depending on how you happen to be measuring concentration on that day. And I just love the contrast between his frowny face and the apple's like smiling, happy face. If only it knew the expression he was making at it. So in this case, like the packet of, this is like an apple flavored thing that you would put into your water to make it delicious and hopefully make this guy smile. And concentration measures how much of that sort of smaller component, the solute, the smaller component, is going to go into your solution, which is your homogeneous mixture of the solute and the solvent. All right. I think that's all I've got to say about concentration.
All right, so now if you see in the left corner, we've added the youngest Dalton family member, this little girl, and she's got her massive hammer that she's using to test her percent strength, this thing that I always failed at carnivals when you smack the thing and it like barely goes up. And so the mass of that hammer and then the percent signs lining up this measuring stick to the bell are our symbol for percent concentration. Or percent composition.
So yeah, here's percent composition. And what I love about percent composition is it's the most straightforward measure of concentration. It's sort of maybe if you have this like little kid be like, okay, well, how should I measure concentration? Well, I should like weigh how much I have of my solute and weigh how much I have altogether and the percent. That's it. That's what's good about percent composition. It's used in making up some solutions. Like I think some like pharmaceutical solutions are like 10% glucose, or if you've ever had like an X% solution. The kind of big brother of percent composition is ppm, which you might have heard of as parts per million, like in the atmosphere or something. So that's what's good about it. It's not used a whole lot other than in just sort of making up solutions, standardized solutions. So if you took Gen Chem, you probably didn't spend a whole lot of time measuring concentrations in percent composition, but it is nice because it's the more, I think, most straightforward one to think about.
And now we've got obviously my favorite symbol in this sketch. We've got the smack-a-mole. And so the big X in the sign and the fact that you've got 1 mole above all the others, like a numerator over the denominator, lets us know that this is a symbol for mole fraction. And
there's the mole fraction. Yeah, and I see something in the chat window. Oh, that just looks like a typo. Okay, so mole fraction is represented by the symbol chi, which looks like a big X, and that's why this is the smack-a-mole extreme. Okay, and a mole fraction always, if you take all the things in your solution and you add up their mole fractions, it has to add up to 1. Sort of like if you were to take mole percent. Oh, that's cute. If you were to take mole percent, your percentages would have to add up to 100%. Okay, so what you need to know about mole fraction that I literally just gave a final exam today for my Gen Chem students that had a mole fraction question on it. And I was grading as I was proctoring, and I'll say about 70% of the students got this right. It's really easy to forget that you've got to have in the denominator all of the species. So this is the moles, number of moles of your stuff, your solute, usually your solute. Sometimes you do solvent, but usually you do solute, divided by the total sum of all of the moles, solute plus solvent. Okay, and just a quick reminder, trying to get those moles. Just a quick reminder, remember the solute is the thing that's there in smaller proportion. The solvent is like the water in your salt water, whatever, the thing that's there in greater percents.
Yeah.
If you all have really fond Gen Chem memories, you'll remember mole fraction from vapor pressure lowering. So there's your fun fact.
Yes.
Yes.
I think back on that all the time.
Okay, yeah, ye old Ralph's law. So that's where you would have applied it.
Yeah.
But not a whole lot of other places does that get used.
Yeah. And a few other things about the symbol that we've got here. As Jen mentioned, your mole fractions will always add up to 1, which is why your score at Smack-A-Mole is also a 1. That would never be my score, though. Just putting that on the record. And then you can see our little mole in their A shirt is up above all the other moles to represent having your moles of A or whatever that component you're interested in is over all the other things. Now, if you really wanted to get technical about it, since your denominator, like Jen says, includes everything, you would also want to count your little A mole down below as well. But that would be confusing to have him in 2 places at once. So
Schrodinger's mole.
That's good. So we're going to move on to molarity next. I think we are moving on to molarity next. So the next symbol is going to talk about molarity, and that's happening here in the dunk tank, where you can see that poor sad little mole. I don't know how moles do in water. Are they okay in water? I don't know.
It feels like
breathe really well without oxygen, so they might be okay. They have special hemoglobin so that they can breathe underground. So
my kids went through a phase where they would like pull up on their screens pictures of wet koalas. Have you ever seen a picture of a wet koala? It's terrifying. Don't Google it. You'll have nightmares. They're so cute when they're dry and so terrifying. I know you're Googling now. So terrifying when they're wet. And moles are pretty scary looking when they're dry. So I don't even know. I don't know what that guy's going to look like if he gets dunked. Anyway, he is hovering over probably more than 1 liter of solution. But the thing you need to know about molarity is it's the number of moles of your solute divided by a liter that are in a liter of solution. Okay, so it's the number of moles per 1 liter. And again, if you are a Gen Chem graduate, you spent a lot of time with molarity. That was the concentration unit you concentrated the most on. You did the most, all of your acid-base stuff, all of your reaction chemistry, your precipitation, all of that you did in molarity. So this is probably the concentration unit with which you're most familiar. Okay, one thing to notice is this evil guy who's trying to dunk the mole. He's over here kind of, well, I'm pointing at him, but he's wearing the pink shirt and the red pants. That ball that he's using has got those little brackets. And you might remember that when you report concentration and molarity, you'll see it in those brackets. And again, this is the most commonly used unit of concentration, moles per 1 liter of solution. And there's an equation. Maybe before we put up the memory jog, let's just see. Does anybody remember if you're trying to dilute 1 solution into making a new solution, and you know the volume of your first solution and you know the volume of your second solution? Let's just see if you can put in the chat window, what equation might you use? This is a little bit, you didn't know I was gonna quiz you today. There we go, Cindy, Josh, Emily, woohoo! Okay, Rachel, you want to take it away for the little memory jog? And if you weren't in the first trio of people, this is what we're going to do. We're going to remind you that M1V1 equals M2V2, or MIVI equals MFVF, initial, final, first, second. And in this case, if you dunk the mole, you have a mighty victory, and the mole kind has been vanquished. M1V1 equals M2V2. There it is.
This is my personal motto.
Okay. So yeah, if you're in a situation where you need to dilute something, which happens a lot in chemistry labs, it does happen in pharmacies too, then you're going to need to know how. And the way you do that is you take the molarity of your first solution and its volume. And then on the other side, you'll have the molarity of the second solution and its volume. And you can solve for any one of those variables. When I always think about this, if molarity is measured in moles per volume, Then you take moles per volume and you multiply it by volume. I guess over here, multiply it by volume. Each side of these equations basically works out to be moles. So really, this is just fancy talk for moles equals moles. Moles before equals moles after. And that's your M1V1 equals M2V2. So that's a nice equation to have under your hat in case you ever need to dunk a mole into a water tank and see what he looks like when he's wet.
Moles equals moles, unless
Moles
you're
are moles.
in which case moles equals dead.
All right. Okay. This program.
So yeah, we've just added Mo's lolly stand off to the right. And we've got a little mole who's about to go for a swim in some molten candy. So we might have another opportunity to answer Jen's question about what they look like when wet. But Mo's lollies, of course, is going to represent molality.
And I'm delighted to talk about molality. And Carmen, I see your question, and I think Ben and Jess will get to that one. They're the pros on score improvement. Maybe right after we do the concentrations, we'll get to that. So molality, not the same as molarity. So molality is a little bit of a weird unit. What's weird about molality is the numerator is not weird. Moles of solute, we do that a lot. Okay, what's weird about it is if you notice in the denominator, it's not solution. It's not your whole solution. What you're doing is you're measuring the number of moles of your solute divided by the mass of your solvent. Okay, and I promise that the gods of chemistry didn't do this just to confuse you. Although when you learned it, you probably thought like, this is just on purpose to confuse me. There is no good reason why my denominator is always everything, except in this one case when my denominator is just how much like my liquid solvent I have. Why would you do that? And so the reason for that, and I'll tell you a little bit about, or I'll let Rachel tell you about the symbol because she's like the symbol pro, but the reason for that is molality is used a lot in, if you remember, boiling point elevation and really importantly, freezing point depression. So molality is how you figure out how much salt you have to sprinkle on your roads to get the ice to melt. Okay, and in a case like that, because you're adding usually a solid to a liquid and you're trying to depress the freezing point, you really just want to know how much liquid you have. You don't want to measure like how did the mass of the salt that I just added over like affect the overall mass or volume of your solvent. You don't care about that. You're kind of like, I've got this much solvent and I want to depress the freezing point by this much. How much solid do I have to add? So that's why it is. But again, molality is moles of solute in the numerator. You're used to that, divided by the mass of just the solvent, not everything. And I think the kilo solver is how you remember that.
Yeah. We've got our little mole friend, and he represents moles of solute, of course, and he is over that kilo solver scale that's giving you a mass of that solvent. And so that helps us remember the formula itself. But then also, if you look over at Mo there on the left, I know his apron's a little bit small in this shot. But if you look at the writing on there, it says candy is sweet, but it's not the solution, with the solution underlined. So that's a little reminder that molality is the one concentration we're going to talk about today, where we're not going to be looking at the solution in the denominator.
Kind of an odd marketing message for a guy who sells lollipops, but okay, sure, Mo, whatever you say.
He wants his customers to take a more holistic approach.
Too honest. Yeah.
And are we going to normality next?
Yeah, I think we're going to have a brief brush up on equivalence before we get there. But
right.
That is the direction we're heading in. So this taxidermy mole, who I don't know who anyone would want to bring home as a prize, his little sign that says 500 tickets equals 1 mole with that big equal sign is our symbol for an equivalent. Which is not a measure of concentration per se, but we're just going to need to know a little bit about them as we go forward with the next 2 measures of concentration.
So yeah, equivalents basically tell you how much of a reactive species or a reactive thing you kind of get out of whatever reagent you're putting into a reaction. So a really good example of this is like a diprotic acid, like sulfuric acid. So sulfuric acid has got 2 acidic protons. So if you add 1 molecule of sulfuric acid, you're going to get 2 equivalents of protons out. So equivalence tells you how much of your reactive thing you're going to get out of each of your reagents, which turns out to be useful because really in any kind of chemical reaction, you want to know how many X's do I need to add if I want to react with a certain number of Y's, something like that. So that's what equivalents do. And also I saw something in the chat window. Is the audio very low? Can you guys hear me okay? Okay.
Yeah, I like always think of equivalence for things like with the redox reaction, they're going to be your electrons that are being moved back and forth, whereas like with an acid-base reaction, that'll usually be protons. So just like sort of whatever that relevant species is that's being transferred and reacting. And so now we've added 2 more little things to the prize table. On the left, you'll see that scale weighing the tickets. I bet that's not how they count tickets anymore. But when I was young, when you like went to an arcade or thing and you had like your big bunch of tickets, I guess they just knew the weight per ticket and they'd actually put them on a scale and divide it.
You totally put like a penny on there, didn't you, to add some extra tickets that you didn't win? Whack-a-mole prize winner, whatever.
You bring your tickets all wet.
Nothing else. Nothing else. I was a nice kid about everything but whack-a-mole. Yeah, so that weight full of those tickets, because we know 500 tickets equals 1 mole for our equivalent side, that weight of tickets is going to equal an equivalent weight, which is basically the weight of one mole of equivalence. And so then knowing that, Jen, you can correct me if I'm wrong. My memory is that that's not one you're going to encounter super commonly.
A whole lot. No.
Yeah, it's pretty straightforward, but not the.
Like equivalents are really, they're more something that you kind of want to get the feeling of so that when you are looking in context at a chemical reaction, you have a sense of, oh, I'm doing this redox reaction and my iron is going to deliver 3 electrons. So for every iron, I need to keep track of it having 3 electrons. But in terms of actually by weight, that doesn't tend to come up that much.
Yeah, exactly. But it's not too bad of a one to remember if you do run into it, because it is exactly what it sounds like. It's just the mass of 1 equivalent. And then off to the right, we've got the normal pop, which is definitely not mole blood. So don't worry about it. And the normal pop represents normality. And so it says 10 tickets per liter down for the price of it. Much, much cheaper than a mole, strangely. But normality is the number of equivalents per 1 liter of a solution.
And this is where if you are going to be doing, again, let's say you're doing an acid-base reaction with a strong base and a diprotic acid, so 2 protons on your acid, then you would say, okay, well, for every mole of acid, I have 2 equivalents of my reactive thing. So for every mole of acid that I have basically twice that in normality, 2 times as many reactive bits in my solution. And again, that comes up a lot. I think it comes the most in redox, where you're transferring multiple electrons in one given reaction. Yeah, and that's normality. Can you guys hear my dog barking? Okay, I'm gonna mute.
It's a cute bark. Yeah.
He's on patrol. He went outside and he's like, people are walking their dogs around here. This is not okay.
And that's it, right? That's the sketch.
We got it all, Rachel?
You're never going to forget. Now, Rachel, washing down her fried Oreos with a liter of mole blood, which is totally normal.
Ah. We were low on dad jokes this time. So.
Yeah, I know. We need
Thanks.
we need to up our quotient.
Yeah, so thank you for encoding all of those awesome symbols. So if you're familiar with Sketchy, we kind of attack it in three parts. So we just encoded these memories, so getting ourselves familiar with the content. If you go on our site, we would do this through a narrated video. So average five minutes, 7 minutes. So we tell a lot of jokes, maybe better ones than we
Yeah, these
said
are the
tonight.
outtakes right here. These are the deleted scenes.
Just so definitely check it out. Really funny. So we walk you through the same thing. Like I said, just better jokes, more humor. And then after that, you have the option to rehearse. So memory consolidation, you can just quickly go through all the symbols. So just kind of quizzing yourself just to see if you did encode everything. And then kind of the last sweet spot is applying it. So retrieving the memories. So quizzing yourself, taking your practice exams. That's really the best way to apply the knowledge. So I think, speaking of applying, it's a quiz time. So we have a few questions for you to practice with. So the first one, give you 10 seconds. Is that enough? It's pretty easy.
You can have 20 seconds even.
20. All right.
See if they can solve this one.
Yeah, see, now we're hitting our quota. That's what I'm talking about.
All right, gang. There we go. There's some answers coming in. I'm not going to say whether you're right or wrong, so we can encourage some other folks. Let's try to get like 3 or 4 answers in, okay?
Yeah, don't forget to change who you're sending it to everyone so that everyone else can see your brilliance, not just us.
Oh yeah, that's right. We can see 2 people, but not everybody else knows that we've got 2. And now I will disclose right answers in. 2 right answers in.
We'll give you a
Keep 'em
hint
coming.
for those.
Yeah, here's a little clue from our sketch.
Oh, will that help them solve it? All right, looking good. Okay, so which measure of concentration uses the quantity of solvent in the denominator rather than the quantity of solution? And remember, this is going to be our weird one. And this is where having that kilo solver in your mind is, I'm going to solve this, is probably going to help. So I saw lots and lots of C's in the chat window, both the secret C's and the public C's. And and if you came in with mole fraction, really nice job. Very, very close. Molality is the only one where we actually have the solvent in the denominator and not the whole solution. And
remember, Mo is counterproductive marketing. Candy is not
the solution.
Yeah,
it's really good. All right, are we ready for another one?
Yeah, should we do another one?
Yeah, let's do it.
Okay, give you a second to read this one. And be careful, everyone, as you do this one.
Should we give a little clue here?
Little clue?
A little tiny hint.
Well, how about maybe if you don't know the answer yet, first in the chat window, thinking back to some of the symbols we used, perhaps the dunk tank. How about you remind us of what equation you're thinking you might apply to this situation? Because this one's a little tricky. If you're motivated to provide the solution. All right, so yeah, Sydney, there we go. Oh, Sydney, you want to say that out loud to everybody?
And the other thing I would say is don't do a bend. Make sure you're answering the question that they're asking, not the question you just want to answer.
All right. Yeah. Okay, nice. Okay, here we go. So we're on the right track. So So we're pretty clear that a mighty victory is within our reach on this question. And we're going to do M1V1 equals M2V2. Okay, so let me read the question to you because this is a tricky one. Okay, professor wants to dilute 3 liters of 12 molar hydrochloric acid solution. I do not want to do that, but to use for a student lab. Okay, so I've got 3 liters. And it's at 12 molar. In the chat window as fast as you can, tell me how many moles I have. 3 liters times 12 moles per liter. Oh, feeling shy. So I've got 36 moles. Okay, so I've got 36 moles in my solution, and I want to add some extra solvent to it. And I want to get to a solution that's 2 molar. Okay, so I've got 36 equals 2 times some kind of volume, right? And so most people are thinking, well, my volume is 18 liters, and that's right. Kinda. It's like kinda right. So I want to have a final volume. Yeah. Oops. I want to have a final volume of 18 liters, but I already have 3 liters there. So my final volume should be 18, but I've already got 3 liters there. So how much extra water or solvent do I need to add? And now everybody in the chat window, as fast as you can, let us know. There we go. There we go. Looking good. Yeah, see, 15 liters. So this one demonstrates the Bend principle. Read the question carefully.
The question they asked.
Yeah. And if you went straight to D, you're not alone. When I first read this, I was like, oh, the answer is D. And I was like, nope. Got to add some.
Yeah, I mean, the good news is if you said D, you probably did all the math and you remembered the concept, you did the math right, and then you just need to make sure you're giving them what they wanted.
Nice job, guys.
Sure.
Way to contribute.
All right, so now it's your turn to ask us questions. So feel free, like I said, to use the Q&A or just throw them in the chat window. And we will stay here as long as you have questions for us. Maybe.
Well, okay, like within reason.
Yeah, so the recording we will post on in our YouTube channel. So be on the lookout for that. And then I believe we'll also email it. If you are on our email, we'll also kind of follow up. And we also have a monthly newsletter. If you're not in our email list, definitely join and we'll throw it in the monthly newsletter. And then I think here's one for you, Jen. Any MCAT examples you can think of for mole fraction and normality, Jen and Rachel?
So in terms of normality, I think it's a good one to know just in case, but I can't think of any good examples. Mole fraction will come up in vapor pressure questions. So that for sure will come up in, what's the vapor pressure of, water that's got some salt in it. What's weird about those ones is you're looking at for the mole fraction of the solvent, which is actually a little bit, you can get the mole fraction of anything, but usually we think about the solvent is not the thing you're finding, but that it definitely comes up in vapor pressure.
Yeah, I'm not saying it's impossible, but I'd be surprised if you had a question asking you to find the normality of something. I think that's one where the reason to know it is really just they could have a passage where they give the unit of something in normality and just sort of being able to look at that and say okay, I sort of know what that's measuring. I'm not going to freak out because this passage makes no sense to me. So that I think it's more helpful in that sense, whereas you probably won't have to do many equations with it.
We do have a question from Joshua who asked, are there practice questions after each sketchy video? The short answer is no, not every video right now. We will be releasing more quiz questions on June 1st, and then look for another huge batch coming in July. So we're getting there. It just takes us time to write all these questions. So wanted to get you all the awesome art and sketches first, and then we're following up with quiz questions. And then Brittany did throw in the chat. So if you guys, we also have a Discord community. So check us out on Discord, really awesome. You know, basically you have access to us, ask questions, you know, be testers, just have all sketchy access, really cool. So check us out on Discord. There's also a link to the survey. So if you have to jump, please check that out. And then we'll wait a few more seconds for any more questions. And we'll get to the good stuff, giving stuff away.
It does make Brittany, who's talking to you in the chat, so happy when you fill out the survey. So, and when Brittany's happy, we're all happy. So help make us happy.
And then I think she kind of also threw a shout out for our ambassador program. So there's a link there to check it out, where you can even apply. So I'm curious. All right. Thank you for some great questions.
Ali has a question. What is the ambassador program?
Brittany is the expert. And I think she said it best. You know, it's a team of awesome students who love Sketchy and want to help promote it to their peers. All right. All right, we're ready for giving away a 6-month subscription. So for anyone interested, feel free to drop your name in the chat and also what score you're aiming for. Just your name and your goal score, and then we'll randomly pick a winner here live, and Brittany will follow up. And then don't worry if you don't win. On the next slide, we'll actually give you a discount code if you're curious and want to buy Sketchy, but then also encourage you to go and try us out. So sign up for a free trial. Right, see some awesome scores. We need the music.
I know, yeah. Gotta put a sound effect button on one of these slides.
Right. Give me like 20 more seconds. All right. The countdown, 5 seconds. Give me 1 second. All right, so congratulations, Allie Williams. You are the winner. So Brittany will be in touch. So
Nice.
congratulations.
Yay, Allie.
Woohoo.
Congrats, Sally.
All right, so
Look at
definitely.
that guy. Little taxidermy
I-
fella.
Yeah, I just had to do that. Just one last look. So definitely check us out, sign up for a free trial. And if you're ready, definitely use the code MCAT May 10 for a sweet 10% off. So. And I think, too, you'll find we didn't really get into too much about pricing, but I think you'll find that we really have priced ourselves nicely because we know, you'll use this as a supplement because you're going to have access to all sorts of resources. So we just kind of want to make it affordable. So you go to our site, our plans start basically at $200, gets you 3 months, which is a nice sweet spot. Our most popular plan is sort of the 6-month at 300. So really nice sweet spot.
Yeah, take it from someone who actually used this to actually do well on step 1. Sketchy is awesome.
Yeah, so I guess if there are no more questions, we really appreciate your time tonight. It's been a blast. Just want to thank you, Jen, too, for your expertise. So it's great hanging out with everyone. Yeah, definitely enjoy your Thursday and have a wonderful weekend.
Come hang out with us on Discord.
Go get some guacamole. Some funnel cakes.
I forgot to make my ultimate joke.